Question 12. A diameter of the circle C1 has the endpoints, these ones here. Find the equation of the circle. Of course, if you have the circle here and a diameter, so let's first put these ones here, -3, -5. Maybe it is this one here, -3, -5. Then this other one here is a 7, so it is on the right of this x coordinate, and then 3. So a diameter passes through the center of the circle. That means we need to get the midpoint of these two to get the center of the circle. So midpoint will be equal to the center of the circle, okay? So we shall have the average of the x coordinates and then the average of the y coordinates. So what do we get here? 7 minus 3, that is a 4, divided by 2, that will be a 2. And then this will be a -2, divided by 2, that will be a -1. Now we need to find the radius. So radius, I can use any of these 2 points. So I can use this one and this one, or this and this, or I can find the length of the diameter, okay? This and this, then I divide it by 2. So whichever way you want. So the radius is going to be a half, okay? Then the diameter. So the change in x is going to be 7, then -3. And then the change in y is 3, then -5. So what do we have here? 10 squared, that is 100. 100. And then here we shall have 8. 8 squared, that is 64. So that is 164. So simplified, this one is going to be 1/2. Then I put the square root of 164. That is root of 41. So root of 41. Now using the general equation of the circle, which is x minus a bracket squared, then plus y minus b bracket squared, which is equal to r squared. The equation of this circle is going to be x minus the center. We are seeing a 2 here. And then when you say y minus -1, that will be a plus, right? So we shall have plus y, then plus 1 bracket squared. And then when you square this one, it will give you the 41. So as simple as that. The circle C1 is translated by this to give C2 shown in the diagram. So it has moved, okay? The center is somewhere here, then it has moved to the right and also here. So it has moved 4 points, 8 to the right and then 4 up there. Find the equation of C2. So the center has shifted by that. Center of C2 is going to be, if the other center is 2, then -1, 2, -1, okay? Now we are going to add 8 units on these 2. So that will be 8 plus 2, and then the y coordinate, -1 here, will increase by 4 units. So plus 4. And then we are going to have this one as 10, and then 3. Then that means that the equation of the circle here is going to be x, then -10 squared, then plus y minus 3 squared, which is equal to r squared. So it will still be 41 because you just shifted this one to there. So the radius never changed, okay? Alternatively, we have this circle here, okay? We have the equation is here. I'm going to just shift this one, put it down here. Now we are having a translation vector. Translation vector is 8, 4, okay? So when you are popping these ones out and you are bringing them where when you pop this one here and you bring it where x is, it comes there as a negative, okay? Transformations of functions. And also this 4, where y is, it will come there as a negative. Pardon me here, this is the equation that we are supposed to transform, okay? Now let us transform this one. So we shall have x then minus 8, okay? Then there is a minus 2 here, and then y then minus 4, but then there is a plus 1 here, then it's equal to 41. Now this one becomes x minus 10 squared, and this one will be y minus 3 squared, which is equal to 41. You see that this is the same answer? Next, the two circles intersect at points R and S. Show that the equation of the line RS is that one. So we are supposed to solve the two equations here simultaneously. Okay? We have this one here and this one here. Okay? We solve them simultaneously. But since all of them are equivalent to 41, all I'm going to do is to get this one and then I equate it to this. Then I expand, automatically we shall get that equation out. So we have, I will say, solving x minus 2 squared, then plus x minus, this is y plus 1 squared, which is equal to 41. Solving this, and the other one is x minus 10 squared, then plus y minus 3 squared, which is equal to 41. I'll just get this equated to this one here. So we shall have x minus 2 squared, then plus y plus 1 squared, which is equal to x minus 10 squared, then plus y minus 3 squared. So when we expand, when we expand this one, it will be x squared minus 4x, then plus 4. Let me try to extend it here. Then plus, you'll have y squared plus 2y plus 1, and then this other side, x squared minus 20x plus 100. Then here we have y squared minus 6y, then plus 9. This one can easily cancel with this. This one can easily cancel with this one. That means this other side we have minus 4x, then plus 2y, 4 plus 1, that one gives us a 5. And then this way we have minus 20x, then minus 6y, then 100 plus 9, that one will give us 109. So we are supposed to make y the subject of the formula. You see this? So bring this one here and then take every other side this way. I mean every other thing the other side. So we are going to have 2y, then plus 6y, then this one will be equal to minus 20 of x, then plus the 4 of x when it crosses. And then we have 109, then subtract a 5. Okay? So this one will give us 8y. And then after getting that 8y, look at the right side, we are having, this is negative 16 of x, and then this one will be 104. Now we shall divide all through by 8. So we shall have negative 16 of x divided by 8, and then 104 divided by 8. So 8 goes into 10 one times, then put a 2 here, it becomes 24. 24 divided by 8, what do you get? 3. So it becomes 13. That simply implies that we are going to have y, which is equal to negative 2x plus 13. And that equation is already out. So where they are meeting, when we try to go back here and we connect these points here, R and S, the equation of R and S is what we have gotten out. Okay, so that is that. Then they are saying that hence show that the x coordinates of R and S satisfy this equation. Okay, so the only thing that we are supposed to do here is to solve y is equal to negative 2x plus 13. Solve this with any of the equations of the circle. I can use x minus 2 squared, then plus, we have y, then plus 1 squared, which is equal to 41. So we shall have x minus 2 squared, then plus, this is negative 2x plus 13, then there is a plus 1. I've written this in the place of y here. I'm solving them simultaneously. Then squared is equal to 41. This will be x minus 2 squared, then plus, this is minus 2 of x, then plus 14 squared, which is equal to 41. Now let us expand. This will be x squared minus 4x, then plus 4, then square this one here, it will give us 4x squared, and then 2 times 2, that one will give us a 4, then times 14, I think that is 56, so minus 56 of x, and then when you square 14, isn't that 196? That is 196. Then bring this one this side, it becomes a minus. So minus 41, that one is equal to 0. Now, this plus this, what do we get? That will be 5x squared. Minus 4x minus 56, that one will give us minus 60 of x. And then 4 plus 196, that is 200. So 200, when you take away 41, automatically you get 159, which is here. So that means we shall have our 159 here. Now, this quadratic equation we have gotten here is the one that we are supposed to solve to give us the x coordinates of the S and R. Then from there, we can substitute maybe in this equation here or in any of the equations of the circles, then to get the y coordinates. So that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.